everyone. Today we're going to be practicing a little bit more with multiplying polynomials, and this time we're going to be looking at special cases. So we have a few special cases that we're going to talk about today. So the first one, notice how in my binomial that I have here 2x plus 3 and then times 2x minus 3, that the only difference is that the first binomial has a plus, the second binomial has a minus. We call these conjugates, so I'll spell that out here. We call these conjugates because one has a plus and one has a minus. Anyway, we can do this problem in two ways, but what's special about it is the answer that we get. So if we use distributive property, we're going to take the 2x from the first binomial and multiply it by the 2x minus 3 in the second binomial, and then we have a plus 3, and we're going to multiply that by the 2x minus 3 in the second binomial. So if we go to now distribute, we're going to get 4x squared and then minus 6x plus 6x, and 3 times negative 3 is negative 9. So what happens when we add a negative 6x to a positive 6x? Those two things cancel out and we're left with 4x squared minus 9. Now let's try it using the FOIL method. FOIL, remember, is first, outside, inside, and last. Okay, so first, I multiply the first two terms together. 2x times 2x is 4x squared. Outside, I multiply the two outer terms together. So 2x times negative 3 is negative 6x. Inside, I multiply the two inside terms together, plus 6x. And last, I multiply the two last terms together. 3 times negative 3 is negative 9. So again, we can see that cancels out and we're left with 4x squared minus 9. So two processes to kind of think about the same thing. It doesn't matter which way you do it, as long as you do it correctly. So let's just take a look at the answer. Notice how we only have two terms here. The reason for that is because we have this plus and this minus. These are conjugates. When you multiply those conjugates together, that middle term kind of cancels out, and that we're left with just 4x squared minus 9. So that's our first special case. So now let's take a look at the next special case we're going to see. In example number 2, we have 3x plus 2 quantity squared. Now, you might be tempted to say, all right, well, 3x squared is 9x squared, and 2 squared is 4, and so that would be my answer. But I'm going to say, no, 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 don't do that, okay? When we square a quantity, what it really means is that we are multiplying it by itself. So this is my base. I'm going to multiply the base by itself, or the base is being used as a factor twice. So I have to write out 3x plus 2 times 3x plus 2, and now I can do what I've done before, either FOIL or double distributive. So 3x times 3x plus 2, and then plus 2 times 3x plus 2, and then we can distribute. So 9x squared plus 6x plus 6x plus 4. And then we can combine our like terms to get 9x squared plus 12x plus 4. Okay, so notice how if we look at the right answer and the incorrect answer, there's a term missing over here, and that's why this one is not correct. So we cannot just square each individual term. We have to write it out twice and distribute, okay? So let's try number 3. Number 3 goes with the same process here. I cannot just multiply the 4x times 4x and the 3 times 3 to get 16x squared plus 9. That's not going to work that way. I have to write it out twice. I need to do that. This is a common mistake that students make, and I don't want you to make this mistake. So when you see a binomial with an exponent and the exponent is a 2, write it out twice. So we're going to do the same thing here. I'm going to take my 4x and multiply it by the 4x minus 3. And now I'm going to take a negative 3 and multiply it by 4x minus 3. And now I'm going to distribute. So 4x times 4x is 16x squared. 4x times negative 3 is negative 12x. Negative 3 times 4x is negative 12x. And negative 3 times negative 3 is a negative 9. So we end up with 16x squared minus 24x minus 9 for our answer. And this is good. What do you think would happen if this exponent were a 3? I'll let you guys think about that. And we'll see you again next time. Bye.